So I chose project for color mixing lamp, and the goal of this project is to mix the color of the lamp from changing the brightness and color of the light of the room. So for example, if my room is dark, then I would like this LED to glow brighter, and if my room is dimmer, if my room is bright, then I would like this LED to turn a little bit dimmer. And let's say if my room is red in color, then maybe I want this LED light to turn something other than red. And if my room is in yellow, then I would like this LED to turn into some color other than yellow. So I make use of the photoresistors and the resistance to change the brightness of the color that it shows. And the ratio of time of the LED spans on and off determines how bright or dim the LED appears, and this is called the pulse width modulation, which I used in this example. So as we can see, I used the LED RGB. I used two different types of resistors. One is with 1000, let me check. One is with 10 kilo ohms and one is with 220 ohms. And then I used the three photoresistors and I wired them with other wires, and notice like I connect the 5V to the positive rail, and I connect the ground state to the negative rail using black and red, and here too I connect all the boards. And for these three, it has to with the PWM, since I was using the pulse width modulation. So the next thing I like to talk about is that the photoresistors work based on the light it received. So basically, if the more intense light is received, then it increases its resistance, and this changes the brightness and the color of this light bulb. And the analog pin right here with here analog in, the A0, A1, A2 is used for the analog function encoding, which I would discuss later on. And so this is basically my circuit board, and if I run a little bit simulation of it, then I change this is the red photoresistors, this is the green photoresistors, and this is the blue photoresistors. If I turn this on, then the light bulb should be red, and if I turn this on, I could choose different brightness. Let's say I want the green to be more green, the light bulb to be more green, and the light bulb to be more blue. So this would be some turquoise color, and if I turn off the red, it would be like turquoise color. And if I turn red all the way up, then all three ons would be white in color. So I could use this switch right now, but in real life, it would be based on the surrounding, the color, the light it received, to change the different color and different brightness of this LED RGB. So this is basically how it works. So I stopped the simulation right now, or actually I could use the code to see. There's the serial monitor. If I stop the simulation, then it basically turn with the data I have in the code right now. So I will show what the code is about. So I put all the comments here. So the first three lines, or actually the first 6 lines, I use the function const int, which stands for constant integer. And this is just setting up the constants for the digital output pin 9, pin 10, and pin 11 to the green LED, blue LED, and the green LED. And this controls the brightness of the light bulb. That is the output. And so this is the output, the digital output pin, and this one's the analog input pin. And this one, I set the red sensor pin to be the A0, the green sensor pin as a variable to be A1, and the blue sensor pin to be A2. So moving on, this one I'm setting, oh sorry, this is not a variable, this is still the constant integer. And this one is the variable. The difference is this one, it cannot change in value, and this one can change in value. So this one, I initially set it as 0, but it would change the value based on how bright or dim the room is. So I add variable red value, green value, and blue value as the output of the red, green, and blue brightness value. And same here for the sensor with the red sensor, green sensor, blue sensor. So this is just setting up, and as I begin, this two lines is to begin the coding to communicate with the computer. And so I wrote a command: this begin serial communication at 9600 bps. So moving forward, we have I used the function pin mode, which basically set the green LED pin right here. The green LED pin is referring to the pin mode as an output. So this is still just setting up, and here is the meaty part of the coding. So let me go through one by one. The first thing is to loop these functions. This is the red sensor value equals to the analog read. So this basically is just reading the sensor values from the analog. So this is working with the photoresistor. It received the brightness of the color in a particular moment, and it takes the value and store it as the red sensor value, and it stores with the green sensor value and the blue sensor value too. But notice that I put the delay 5 in between them. The 5 is referring to milliseconds, and this is because the analog to digital converter takes about a millisecond to do the work. So 5 millisecond would be a proper number for the conversion to work, while it still works at a fast rate that we could see it glow dimmer or brighter instead of seeing it flashes. So this command is used for the serial monitor. So this just print out the values that it obtained, the red sensor value and the green sensor value, the blue sensor value. It prints out the value of it that it reads from the photoresistor. So the black dash T is equals to a tab in computer. So notice here, green 54 tab, blue 54. So this is the backslash T, and here is the print out end. It's just returning every line. So notice here, map sensor value. The next line is raw sensor value, which is the next code here. This is just returning a line, so it looks better in the serial monitor. And basically, it also explains these codes too. It's just printing the number. It's just printing the characters and printing the number, and it's easier to track the numbers down. So moving on, I want to go through these 3 lines. These 3 lines are the conversion from the red value to the red sensor value, which is basically, we have the value from the photoresistor. It's from 0 to 1023, but since the 1023 doesn't work on the brightness of the LED, and we have to convert that to a number that works to turn the brightness of the LED. So we have to divide it by 4, since this is the scale that it is used to this is the scale it used to convert the sensor readings to the duty cycle, which is from a value of 0 to 255. And I have to do it 3 times since I have 3 different components, red, blue, and green. And then after computing all the numbers, the last 3 lines is the mechanism of the whole Arduino board, which is to change the brightness of the red LED based on the value of the sensor reading with the amazing code analog write. And it is based on the value of the sensor reading and the duty cycle, which is the red LED pin and the red value I have on top here, which is collecting the brightness and the brightness of each photoresistor from the surroundings. So yeah, this is basically all the codes I have here, and yeah, this is the end. Thank you.